All right. Polygon is a closed shape with the same number of sides and angles. That's the definition. That's a short definition of polygon. We have something called convex polygons and concave. The biggest difference is that a concave polygon will have a reflex angle. Okay? Do you remember that? What a reflex angle? It's larger than 180 degrees. Okay? That's what a reflex angle is. You don't have to worry about it too much because we don't deal with concave. We only deal with convex. Okay? This is what you're going to see all the time. Like, I haven't done a concave in this unit. Okay? Then we have something, we separate between regular and irregular polygons. We have two categories there. What is a regular polygon? It needs to meet two criteria. All angles are congruent. I would add this to my study sheet. What is a regular polygon? All angles are congruent and all sides are congruent. Just that part I would add to my study sheet. So anything that doesn't meet these two checkboxes is going to be placed in the irregular polygon category, all right? So you don't have to have a definition for irregular, you just have to have a definition for regular. If it doesn't meet these criteria, boom, you're irregular, okay? So for example, this triangle right here, if all three sides are the same, we actually have a name for it. Remember what it's called? Equilateral triangle, yes. And if all three sides are the same, folks, we also know that all angles are measuring the same as well. They're all 60. So this one checks out, right? All angles congruent. Check. All sides congruent. Check. That's why it's in the regular camp. Okay? What about this one over here? This one has two sides that are the same. This one is called an isosceles, right? Isosceles triangle. When you have two sides that are the same, folks, watch the pattern. The angles across from them are also going to be the same, and this is how we label it. Okay? So it has, right, all sides. Sorry, let's start with angles, be consistent with the other side. All angles congruent? No, right? All sides congruent? No, so it's in the irregular camp, okay? The other type of triangle, I'm just gonna call it so you know the name if it doesn't throw you off. Anything that isn't one of these two is called a scalene triangle. You remember that? Have you ever covered it? I don't know. Scalene triangles, there we go. Next, a square. All four sides are the same. Therefore, all four angles will have a 90. Okay? So all angles congruent. Check. All sides congruent. Check. What about this one, the rectangle here? A rectangle has four 90s as well. Here's where it gets a little interesting. Okay? Can you say that all angles are congruent? Yes, right? They're all 90? Check. Oh, will it meet the criteria? All sides congruent? Fail, right? So that's why it's in the irregular polygon category. Okay? So I'm not going to talk about this one. I just wanted to give you some. You can tell by the shape, if you were to sketch it, you should right away, it's like this one is definitely not regular. This one has all four angles the same, but the sides aren't. So it doesn't meet the criteria for regular. So just so you know, I will ask you in various ways, do you understand the difference between? Okay. Properties. All polygons have interior and exterior angles. Interior and exterior angles are supplementary. They have a sum of 180 degrees. So I'm going to use a different color here. I'm going to use blue and red. I don't know what you have, but to really emphasize the point. Okay. Is this a regular polygon? My pen is right on it. It's definitely not, right? You can tell the angles are all different. But how many sides does this have? 5. So there's something I already want you to know. Number of sides, we use the letter N for it, is 5. Okay? So that's how I'm going to start with, and I'm going to add to it later. The interior angles are formed inside that shape wherever two sides meet. So there's one there, one there, one there, one there, one there. And I'm going to use capital I for all of them. So how many interior angles? Right. Number of interior angles, we call them I, is also 5. I don't think you don't seem terribly surprised there. And that's all right. Next, for this part you need to pay close attention. There's something called exterior angles. They're on the outside of the shape. This is how you find the exterior angle. You're going to travel along one of the sides that meet there. Okay, so I'm going to pick this side. So you travel along it, and when it goes off to the other side, you actually extend the side you were traveling on, like so. Dashed, okay, because it's not part of the shape. But that is your exterior angle right there. Between that dashed line and the other side of the polygon, that's what we call the exterior angle. And we keep traveling. I kind of start here and then I keep going around. So if you travel along this side and it ends, you just continue the same path as if you forgot to turn the corner, right? And this is your other exterior angle right there. And we continue that. I'm now going to travel here, and when it stops, I just continue it in the same angle. You're going straight along that side that you were traveling on. There's another E right there. Continue, travel here. There's your E right there. And last but not least, down here, there's your E right there. How many exterior angles are there? 1, 2, 3, 4, 5, right? So number of exterior angles, we call them E, is also 5. So there's a relationship between the number of sides, interior and exterior angles, okay? So, a couple things I want to summarize here. If you look at the I and the E, can you tell that they're going to add up to 180? Yes. So that's the big property here. So I plus E are always going to be equal to 180 degrees. I would add that to my study sheet as well. I hope you know what the I and the E stands for. So you might have to tell yourself, maybe you have to have a little diagram like this and just tell yourself that, okay? That I and E are stemming from here, okay? And the next thing is watch this, sum of exterior angles is always 360, regardless if it's a regular or irregular shape, regardless of the number of sides. That honestly deserves highlighting, and I would say it deserves a spot on your study sheet. Make it small, right? And this is the main the main point I'm trying to make. It's always 360. It's, you know how a triangle, like the sum of interior, is always 180? But that's for a triangle. It's only for a three-sided shape. Sum of exterior angle is always 360. Okay? It could be a triangle. It could be a rectangle. It could be a pentagon, octagon, any gons, right? It doesn't matter. If you were to add up what the exterior angles add up to, it's always 360 degrees. That's a pretty cool property to know. So make sure that finds its way. Because I ask you like a lot of true and false questions. I will present a problem to you. You have to figure it out. So remember that. Okay. No formulas so far. But here we go. Oh, I'm going to give this a highlight too here. How is this so helpful? How is this such a big deal? Because, watch that, stemming from that is this. You could potentially say, hey, to find the exterior angle, I'm just going to go 180 degrees minus I. I'm going to subtract the interior angle to figure out what the exterior is. Or from that, you can stem and say, to find the interior angle, I just go 180 minus E. Okay? These are not necessarily, you don't have to have them on your study sheet, but it does help to know those two. Okay? So if I told you this, watch this. If I told you that the interior angle is 120 of this, whatever polygon we're looking at, if I tell you that this is 120, you should know, okay, the exterior angle is 60, right? If this is 150, you should know that the exterior is going to be 30. Without even drawing it, without anything, you should just know, I know that I and E always add up to 180. Okay. Fun stuff, eh? Keep going. Page 33. Formulas. Ahead of time, eh? Okay. Formulas where n is the number of sides. Okay, that's don't ask me who came up with that, but should have been s, right? Number of sides, but maybe number of sides. Anyways, n for us is the number of sides. Okay. So what do they represent? I tried. Okay. I want you to be psyched for polygons. I know it's not how you spell it, but maybe it helps you remember. S-I-C-E-D, okay? Mr. Dirksen, it says sized. It's not psyched. But anyways. So the sum, right? The sum of all the interior angles given n number of sides would be n minus 2 times 180 degrees. So that's the sum of interior angles here that you're finding. Okay? All interior angles added up together, if you want to rephrase that. Next, I of number of sides is n minus 2 times 180, so it's almost copy-paste. You see that? But what's different here? You're going to divide it by the n. This is the interior angle. So this formula calculates the measure of each interior angle. Only works with a regular, it's only when it's a regular polygon that you can use that one. C. What does C stand for? Well, you're going to have to take 360 divided by the number of sides. What does it do? It calculates the measure of each central angle. Also, it would only work if the polygon is regular. So that's important for you to make note of in your study sheet. Watch exterior angle. It's 360 degrees divided by n. It calculates the measure of each exterior angle. It has to be a regular polygon though. Hold it, Mr. Dirksen. Didn't you just tell us that E is 180 minus I? Didn't you just tell us that? That is correct. If you know I, use that one. But oftentimes you won't know, you will just know the number of sides, then use this one. And it has to be regular. Okay? Last but not least is the D is n times n minus 3 over 2. What does it do? It calculates the number of diagonals that can be drawn. Okay? I will show you what all of those mean in a bit. What I want you to remember is that ice, see that? Ice is only works with regular polygon. Right? So if you, I will just write that down, regular poly. Okay, so on your, maybe you don't want to have all of this on your study sheet, but you want to have this, you go for it, okay? Moving further down here, I'm going to first show you ice. Ice you can actually identify on a diagram, on a polygon. So here we go. I think I you already know. So this one has how many sides? 1, 2, 3, 4, 5, correct? So 5 sides. N is equal to 5. Therefore, I know I have 5 interior angles, correct? So 1, 2, 3, 4, 5. I. Does this one look regular to you? If you say yes, you're correct. This one looks regular for all intents and purposes. All sides are the same. All angles measure the same. So if I ask you to identify, listen, I will probably only ask you to identify one interior angle. I've identified all 5. Okay, that's all I've done here. And let's do the exterior as well. This is E. This is E. Mr. Dixon, what if I go counterclockwise or clockwise? Does it matter? It doesn't matter. Just make sure there's only one E at every intersection. You shouldn't have 2 E's showing up. Maybe I'll talk about the most common mistakes that I see for exterior angles. Some students just go to any corner. You ready for this? And they just go out into space like that. That is incorrect. That's not an exterior angle. To be sure you're doing this right, pick one of the sides and just travel along that side and then just continue that same pattern. Then you're going to for sure find your exterior angle. Okay, so don't make that mistake. And central angle. Ready for this? Central angle, you find the center to the best of your ability and you slice it up. I'm going to use a ruler. If you have one, you can. If not, don't worry about it. We're just going to identify one central angle here. So the key is you need to span one of the sides and cut your pizza slice like that. Okay? And then that angle right there, it gets a C. How many central angles do you think there will be? 5. You guessed it. 5 pizza slices, right? Think of it that way. And so that angle is called C. Okay? All right, let's calculate it. If I asked you to find the sum of all interior angles, you would go like this, S of 5. Use the formula. It calls for 5 minus 2 times 180 degrees. 5 minus 2 is 3, so it'd be 3 times 180. So that's 540 degrees. So what did I just find here, folks? If I were to grab all the eyes and just add it all up, yeah, sum them up, you get 540 degrees. The more sides your shape has, the bigger this number is going to get. I hope it makes sense, right? Because you're going to have more angles that you're adding up. Mr. Dirksen, does this work for a triangle? Yes, it does. S of 3, just do this with me in your head. S of 3 would be 3 minus 2, that's 1, right? 1 times 180, 180 degrees. So it works for any shape. Interior angle of a five-sided shape calls for n minus 2. It's always n minus 2 times 180 degrees. But this one calls you to divide by n. We already know that the top part is 540, correct? The top part, we're not going to redo it because it's the same. So we take 540 in a sense, and you split it equally amongst 5 angles. That's what you're doing here. And that's 108 degrees. What are we going to do next? Central. Central angle for a 5-sided polygon. We're going to go, what does it call for? C, 360 degrees divided by n. Hold it, before we do, we go ahead. This is going to be 72 degrees. Next, we're going to do E, exterior angle of a 5-sided shape. It calls for 360 divided by n as well. So that's kind of interesting that those two are the same, always, if it's a regular. Do you notice something about the interior and the exterior? What do they add up to? So could you have just, I could say this, or E is equal to 180 minus I, 180 minus 108, it's still 72. I know your mind is blown, right? So either way is a possibility here. When do I use this one? When I know I already. Like if I know I, I'll just subtract it from 180, then I have my exterior angle. Okay? And last but not least is D. D is the number of diagonals, and I'll try to sketch that for you in a bit. It calls for n times n minus 3 divided by 2. It's always divided by 2. Make sure you have that formula right. That's 5 times 2 divided by 2. You can go 5 times 2 is 10 divided by 2 is 5, or you can just cancel out the 2's. There's 5 diagonals. This is not a degree. This is the number of diagonals. And what in the world is that, Mr. Dirksen? This is what it is. I'm just going to try my best here because I'm not an artist. Okay, so I'm going to try to draw a pentagon here. These are your diagonals. Ready? You start at any corner. So from here to here, that's 1 diagonal, 2 diagonals. So I'm done there. Then I go to my next point here. That's number 3 and 4. And I'm missing 1. In this corner, I can still connect here. So you're able to draw 5 diagonals in a pentagon. But this number isn't at all related to the number of sides. It's pure coincidence that it's 5 as well. Okay, as you get higher in the number of sides, this number goes up significantly. I would never recommend you drawing it because you will probably miss 1 for sure. So because it's small enough, I was able to do it. So that's psyched, okay? So we've calculated them all. These 3 can actually be represented and found on my polygon. Well, D technically you could also sketch, but some S is not identifiable on here, okay? Let's keep going. I'm going to ask you too. Let me see here. I wanted to do working backwards yet. So 34, we're going to put it on hold. Let's go to 36. Go ahead. 36, working backwards. So how do working backwards, how does that go? Well, sometimes you'll be given one of the psyched values, right? So one of those, you'll be given the values, you'll be asked to determine the number of sides. Here's the kicker right there. You have to work backwards to find out how many sides would this polygon have, given that information you just gave me. Start with the appropriate formula, then isolate for n. That's how we go about it. So, we're told that the sum of interior angles of a polygon is 3,060. Determine the number of sides. Because it's saying this, we're told that the formula is S of n is equal to n minus 2 times 180. Okay, we start with our formula. Where does the 3060 gonna go? This actually tells us that this number that we used to calculate, we already know what it is. So we're gonna replace that with 3060. Is equal to n minus 2 times 180 degrees. And what do you do there? That's up to you how you want to go about it. Some students want to probably distribute. Let's distribute the 180 into this bracket. I would not do that because it's going to make things complicated. Instead, I'm going to divide both sides by 180 degrees. And that's going to allow me to, because these two are multiplying, I can do that. I can cancel out here. On the left side, you just perform the calculation, right? So 3060 divided by 180 is 17. You're left with n minus 2 on the other side. This 2 here is going to come over to the other side. So it's going to be 17 plus 2 is equal to n. And I ran out of runway there, sorry. I'm going to continue here. I now know that 19 is equal to n. Oh no, Mr. Dirksen, the n always has to be on the left side. Nope, it doesn't. It's all good. N is equal to 19 regardless. So this is what I call backwards. Okay? Let me see here. What's our time? Still have a little bit of time. Can you try B? I'll just give you 2 minutes or 3 to try B, because that one is actually not too bad. And then if you're already up for the challenge, you can try C, but if you just want to wait for me, that's fine. But it says the regular polygon has an exterior angle of 11.25. Calculate the number of sides algebraically. You don't guess and check. Actually show me the work, okay? I'll be with you. Here we go, guys. So I give you the exterior angle. So you should start with this formula. So the 11.25 goes in here. Okay. And this is going to be probably your favorite out of all. What do you see there? Cross multiply and divide, hopefully. The power of 1. So you have to cross multiply and then divide. So you just go 360 times 1 divided by 11.25. So n is equal to 32 sides. There you go. That one is the fastest of all when you have one of those formulas where you don't even have to do adding or subtracting. Last one here. A regular polygon has interior angles of 171 degrees. Calculate the number of sides algebraically. What this word means is show work. Okay? Show your work. So you need to make sure you do that. This is the formula for interior angles. Leave a little bit of side on the right side because I'll give you a shortcut for this. This is n minus 2 times 180 over n. Make sure you write this down. We know that 171 is going to go in there. Okay, so 171 degrees is equal to n minus 2 times 180 degrees over n. What I would do here is I like to get rid of whatever is in the denominator. So I'm going to multiply both sides by n. So I'm going to go like this, times n, and I take this side and I multiply it by n as well. In doing so, I can cancel out the n's on the right side. On the left side, 171n is what you end up with. Okay? And on the right side, it's n minus 2 times 180 degrees. Here, unfortunately, you have to distribute because on the other side you have 171n, not just 171. Right? The very first example, we had a number there. So I'm going to distribute. I'm going to go this times that, this times that. Okay? So 171n, it doesn't matter which one you do first, 180n. 180 times negative 2 is negative 360. And whenever you have variables on both sides, you want to kind of bring them and combine them. So what I'm going to do is I'm going to take this 180n, I'm going to bring that term over to this side. So 171n minus 180n is equal to negative 360. 171 minus 180, that's negative 9n is equal to negative 360. I don't like those negatives. It's going to solve right here. It's going to dissolve, I should say. Negative 9, negative 9. We divide both sides by negative 9 in this case. That gives us positive n on this side and positive 40 on the other side. So this is by far the most complicated one. But here's the shortcut. You ready? You can say, do it that way, or do you remember what I said? If I know the interior angle, how would I find the exterior? 180 minus I? Let's do that one. So what's E going to be? 180 minus 171 is 9 degrees, correct? So this question, when they give you the interior angle, they're also basically giving away what the exterior angle is. It's 9 degrees. And we just did the exterior angle up here, didn't we? Watch. We just did that here. So you're turning this question into question B. Either way, you're going to find out the number of sides. So you're going to say E of n is equal to 360 over n. The 9 goes in there. The power of 1, 360 times 1 divided by 9. And n better be 40, right? It should be the same. So you choose which one you want to do. Which one appeals more to you? This just requires one extra step. And then you turn it into basically a cross-multiplying and dividing situation. All right. We're almost out of time. So I'm just going to ask you to do, I'm going to just say page, let me see here, page 34. If you can do page 34 and, hold on, homework, page 34 and 37. So I'm going to page 34 and just writing this up top. Page 34 and 37. I'm probably going to post more than just that, but I would like you to have to give that a try. Very important moving forward because we're going to deal a lot more with polygons now. Okay. 34 and 37 is your homework. So just go look for those 2 pages amongst the key that I'm about to post. Thank you guys, you did great.